for a deeper explanation of the principle of mentalism, then you're in the right place. I'm about to reveal some easy ways to understand this principle without having to bring the information together yourself. I understand that not knowing the science behind the principle of mentalism can be frustrating for those who want proof. But don't worry, because today I'm going to share with you the science behind the Hermetic principle of mentalism. And I just want to start out just by saying, as far as what we call God or the all, you you can't really understand it in its fullness. What we're doing right now is just attempting to derive the principle of mentalism from science. So let me just double check y'all, make sure my camera's up. As you can see, I have a video. I have a few videos I'm going to be sharing with you guys. So I'm going to leave this up for right now until it's time to start it. And I'm not going to be showing the whole videos, but just different parts to help you better understand what we're talking about. So the principle of mentalism says that all is mind. And this can be difficult to understand because everything around us seems so real and physical. So when it comes to the physics that describe what the nature of matter actually is, um, outside of consciousness, matter doesn't exist. Basically, meaning everything is mind, or the principle of all is mind, and there is no existence of anything outside of the mind. So physics is where we need to start to understand this concept. So Max Planck was a German theoretical physicist whose discovery of energy quanta won him the Nobel Prize in physics in 1918. He is among many who proved the idea of mentalism to be true. So, quote from Mr. Planck explaining his view. Um, as a man who has devoted, start quote, as a man who has devoted his whole life to the most clear headed science, to the study of matter, I can tell you as a result of my research about the atoms this much. There is no matter as such. All matter originates and exists only by virtue of a force which brings the particles of an atom to the vibration, and it holds the most minute solar system of the atom together. We must assume behind this force the existence of consciousness and intelligent mind. The mind is the matrix of all matter. Max Planck's from the New Science. Give me 1 second, y'all. Let me just check my connection, because I am in the public place and I'm not familiar with. I've never streamed from here before, so I just want to make sure my connection is good. Because if not, we'll just end it here. I'll do the video off live and then I'll repost it. But it looks like we're still good to go. So let's continue. So quantum mechanics is our first step in proving the principle of mentalism is true. In order to really get a grasp on the conclusions that derive from the principle of mentalism, we should look at the history of quantum mechanics. So Niels Bohr and Max Planck were two of the founding fathers of quantum theory, and each received a Nobel Prize in physics for their work on quanta. Einstein is considered the third founder of quantum theory because he described light as quanta in his theory on the photoelectric effect, for which he won the 1921 Nobel Prize. So unless light was treated as a particle, black body radiation could not be solved. That particle is a photon. The word photon from the Greek means phos or light, and it is a type of elementary particle. It is the quantum of the electromagnetic field, including electromagnetic radiation. such as light and radio waves, and the force carrier for the electromagnetic force. So, this idea originated with the double slit experiment. In modern physics, the double slit experiment is a demonstration that light and matter can display characteristics of both classically defined waves and particles. Moreover, it displays the fundamentally probabilistic nature of quantum mechanical phenomena. This type of experiment was first performed using light by Thomas Young in 1801 as a demonstration of the wave behavior of light. At that time, it was thought that light consisted of either waves or particles. With the beginning of modern physics, about 100 years later, it was realized that light could, in fact, show behavior characteristics of both waves and particles. So in 1927, Davison and Germer demonstrated that electrons show the same behavior, which was later extended to atoms and molecules. Thomas Young's experiment, which with light, was part of classical physics long before the development of quantum mechanics and the concept of wave particle duality. So he believed it demonstrated that the wave theory of light was correct, and his experiment is sometimes referred to as Young's experiment or Young's slits. So the experiment belonged to a general class of double path experiments in which a wave is split into two separate waves that later combine into a single wave. Changes in the path lengths of both waves resulted in a phase shift, creating an interference pattern, another version of the Mach Zehnder interferometer, which splits the beam with a beam splitter. So, in basic version of the experiment, okay, a coherent light force, such as a laser beam, illuminates a plate pierced by two parallel slits, and the light passing through the slits is observed on a screen behind the plate. So the wave nature of light causes the light waves passing through the two slits to interfere, producing bright and dark bands on a screen, a result that would not be expected if light consisted of classical particles. However, the light is always found to be absorbed at the screen at discrete points as individual particles, not waves. The interference pattern appears via the varying density of these particle hits on the screen. Furthermore, versions of the experiment that include detectors at the slits find that each detected photon passes through one slit, as would a classical particle, and not through both slits, as would a wave. However, such experiments demonstrate that particles do not form the interference pattern if one detects which slit they pass through. These results demonstrate the principle of wave particle duality. So, although the experiment showed that light was a wave, it was Planck that demonstrated that light was both a wave and a particle. Later, it was demonstrated in the Davison-Germer experiment in 1923 through 1927, an experiment by Clinton Davison and Lester Germer at Western Electric, later Bell Labs, in which electrons scattered by the surface of a crystal of nickel metal displayed a diffraction pattern. This confirmed the hypothesis advanced by Louis de Bro forgive me, Broglie in 1924 of wave particle duality, and was a Broglie in 1924 of wave particle duality, and was an experimental milestone in the creation of quantum mechanics. So basically, this was a confirmation of the forming of the interference pattern among electron and photon waves. So the word interference is derived from the Latin word inter, which means between, and fere, which means hit or strike. and was coined by Thomas Young in 1801. So this created a proposition that may be true. So an equation was created called the Schrodinger equation that suggested the theory true. In the Schrodinger equation, it was found that a linear particle differential equation that governs the wave function of a quantum mechanical system. It is a key result in quantum mechanics, and its discovery was a significant landmark in the development of the subject. The equation is named after Erwin Schrodinger, who postulated the equation in 1925 and published it in 1926, forming the basis for the work that resulted in his Nobel Prize in Physics in 1933. From this, he suggested that both the electron and the photon were both a particle and a wave. So what Schrodinger's equation proposes is the idea of superposition. So superposition is the ability of a quantum state to be in multiple states at the same time until they're measured. However, when photons and the electrons are observed, they have defined states. Excuse me. However, when the photons and the electrons are observed, they have defined states and also have a defined space and time. When they are not observed, though, they are smeared out in a wave of probable locations and states. Remember our definition of superposition. The Schrodinger equation revealed what's called wave function. A wave function in quantum physics is a mathematical description of a quantum state in an isolated quantum system. But this still doesn't make sense when you think about our world. The way we conceive it is that whether we are observing matter or not, that it exists and it has definite properties. But that is not what quantum mechanics is telling us. So, of course, they did another modified experiment later, shooting particles through the slits one at a time, or single particles through the slits. So the idea here was that if there is only one particle going through, then there is nothing else to interfere with it. So despite sending the particle through one at a time, they still formed the interference pattern. So although there was nothing else to interfere with it besides itself, they were still interfering with something. So this deduced the probabilities of wave function with definite states to possible states of wave function. So afterwards, what was found was that when the electron was trying to be measured by observing what slit it would go through, the electrons would clump up or they would interfere rather than assume wave patterns again. So the simple act of observing the waves caused them to change states as a different particle altogether with different properties. So let me just check my connection, y'all. Just make sure we still on here. All right, cool. 13 minutes in. Right. So that this is what is referred to as the wave function collapse. So in quantum mechanics, wave function collapse occurs when a wave function, initially in a superposition of several uh, eigene states, reduces to a single eigene state due to interaction with the external world. So this interaction is called observation. So now the question here is that of observation itself. What is observation? So in physics, an observable is a physical quantity that can be measured. Examples include position and momentum. In systems governed by classical mechanics, it is real valued function on the set of all possible system states. In quantum physics, it is an operator or a gauge where the property of the quantum state can be determined by some sequence of operations. For example, these operations might involve submitting the system to various electromagnetic fields and eventually reading the value. So this is not necessarily a wrong way of looking at things, but consciousness also has to be taken into account as part of this measurement because the very apparatuses used to observe are made of quantum particles themselves and must also themselves be measured to take on definite states. So what or who collapses the wave function of the measuring apparatus? Just simply meaning if I'm observing something, what is observing me? Like if I'm observing something to measure it, what is measuring the observation apparatus because it's made of the same stuff. So this is where perception comes in because observation is not objective, rather it is subjective, and or the observer determines what is observed. So the observation will depend on the frame of reference of the observer. That means consciousness is included in the frame of reference for the collapse of the wave function, the collapsing of the wave function. So there is the idea that decoherence causes collapse before the wave is observed. So quantum decoherence is the loss of quantum coherence. This raises the question, though, of what is decoherence to begin with. And decoherence has been used to understand the possibility of the collapse of wave function in quantum mechanics. Decoherence does not generate actual wave function collapse. It only provides a framework for apparent wave function collapse as the quantum nature of the system leaks into the environment. That is, components of the wave function are decoupled from a coherent system and acquire phases from their immediate surroundings. So if the environment, which is made up which is made of quantum particles, has not collapsed due to observation, how is it that the wave particles that are comprising the environment collapse unless they're observed too? So also, if consciousness is taken into account of the measuring apparatus, then if the environment is made of the same stuff, we have to assume that the environment has consciousness as well. With all this, consciousness has to be involved and taken into account. So ideas like decoherence center around physicalism. In philosophy, physicalism is the metaphysical thesis that everything is physical and that there is nothing over and above the physical, or that everything supervenes on the physical. In physicalism, if physicalism is the case, though, then there would be no grounds to exclude the mind from the collapse of the wave function. So in science, every other object observed collapses the wave function. So special pleading is an argument in which the speaker deliberately ignores aspects that are unfavorable to their point of view. So this is the only way to exclude consciousness as a measurer of quantum. So the exception to the physical world must be the mind. So the scientific evidence just presented to have a prejudice to an idea contrary to physicalism is unjustified. So here we've established the fundamentals of physics and mentality. Through the observer effect, we can see that something affects the physics through the mind. There's another argument that there are variables that are hidden that are causing the wave collapse function that are not consciousness. In physics, hidden variable theories are proposals to provide explanations of quantum mechanical phenomena through the introduction of unobservable hypothetical entities. There are, excuse me, there are two hidden variable theories that are local and non-local. And it's worth mentioning that though that physicists such as Elaine Aspect and Paul Quate have performed experiments that have found violations of these inequalities up to 242 standard deviations. This rules out local hidden variable theories, but does not rule out non-local ones. So this showed that Einstein's theory of spooky action was real. This spooky action, or action at a distance, when applied to a photon, means in physics is the concept that an object can be moved, changed, or otherwise affected without being physically touched, as in mechanical contact by another object. That is, it is the non local interaction of objects that are separated in space. Just check my connection. All right, we still on. Let's keep it going. So this also showed that entanglement was a feature that was unavoidable when it came to any science that would take the place of or replace quantum physics. Quantum entanglement is a physical phenomena that occurs when a group of particles are generated, interact, or share spatial proximity in any way such that the quantum state of each particle of the group cannot be described independently of the state of the others, including when the particles are separated by a large distance. All right, y'all, just double checking my volume, making sure you guys can hear me. So, regardless of the distance in between them, though, if one is affected or one particle is affected, then the other one should be affected as well. With this in mind, that means if there are variables, that the existence of non-local variables is present. The problem comes in because the collapse of wave function happens in an instant. So if there are hidden variables that do exist in the pre-existing quantum state of physical reality, then the second particle that is affected must be being affected at an infinite speed. But according to special relativity in physics, the special theory of relativity, or special relativity for short, is a scientific theory regarding the relationship between space and time. And according to that theory, nothing is faster than the speed of light, not even hidden variables. So even non-local variables violate the laws of physics. So what's being demonstrated here is that the links between these physical particles are not in space-time, but they exist in space-time. However, the laws of physics extend across the board. So even at the micro level or the macro level, it doesn't matter. The laws still apply. The Leggett-Garg inequality was used to test these theories, named for Anthony James Leggett. And Anupam Garg is a mathematical inequality fulfilled by all macro-realistic physical theories. Here, macro-realism or macroscopic realism is a classical worldview defined by the conjunction of two postulates. In quantum mechanics, the Leggett-Garg inequality is violated, meaning that the time evolution of a system cannot be understood classically. Basically, the hypothesis of macro realism failed the experiments. There were two other experiments done that found similar results. In quantum mechanics, the Cochin-Specker theorem, also known as Bell-Cochin-Specker theorem, is a no-go theorem, proved by John S. Bell in 1966 and by Simon B. Cochin and Ernst Specker in 1976. So the quantum Cheshire cat is an effect introduced recently within the weak measurements framework. The main feature of the QCC effect is that a property of quantum particle appears to be spatially separated from its position. So these two experiments were based out of ignorance of what actual science is saying. Werner Karl Heisenberg was a German theoretical physicist and one of the key pioneers of quantum mechanics. He published his work in 1925 in a breakthrough paper. This is what he said. He said the ontology of materialism rested upon the illusion that the kind of existence, the direct actuality of the world around us, can be extrapolated into the atomic range. This extrapolation is impossible, however. Next, there's the argument that no one really understands quantum mechanics fully, so we can draw no conclusions for our lack of understanding. So Richard Feynman once said, "I think I can safely say that nobody understands quantum mechanics." It is one of the most repeated quotes of Richard Feynman and is undoubtedly an unusual phrase coming from the mouth of a physicist. So Feynman suggests that we use quantum mechanics as a tool rather than using it to tell us anything about reality. So compared to metaphysical realism, the only philosophical problems that quantum mechanics has is not so much problems, but more inconsistencies. So the understanding of quantum mechanics is not likely. The understanding of quantum mechanics on the grounds of materialistic realm is. However, of all of these opinions, it's not actually part of science. So when we do look at the science, we can see that the idea of materialism doesn't fit with the view that in the world, the mind is the observer. So opinions can easily be dismissed without evidence, whether they're true or not. Let's get some water real quick, y'all. So we just finished looking at the observer effect. So just check my connection, y'all. Look like we still good. So in physics, the observer effect is the disturbance of an observed system by the act of observation. So now we're going to look at quantum gravity. So quantum gravity is a field of theoretical physics that seeks to describe gravity according to the principle of quantum mechanics, and where quantum effects cannot be ignored, such as in the vicinity of black holes or similar compact astrophysical objects, and where the effects of gravity are strong, such as neutron stars. So, quantum gravity is the combination of quantum physics with Einstein's theory of general relativity. So, one of the difficulties in of formulating a quantum gravity theory is that quantum gravitational effects only appear at length scales near the Planck scale, around 10 to 35 meters. Excuse me, y'all. A scale far smaller and hence only accessible with far higher energies than those currently available in high energy particle accelerators. So, therefore, physicists lack experimental data which could distinguish between the competing theories which have been proposed and those. Thus, thought experiment approaches are suggested as a testing tool for these theories. So, despite it being unfinished, there are ideas that many do agree with. So, what are those ideas? The first is the idea of a holographic universe. So, the holographic principle is a tenet of string theories and a supposed property of quantum gravity that states that the description of a volume of space can be thought of as encoded on a lower dimensional boundary to the region, such as a light like boundary, like a gravitational horizon. So basically, the three-dimensional universe is in its entirety comes from information processing of two-dimensional. So at first, this was just an idea proposed by Gerard Hooft. It was given a precise string theory interpretation by Leonard Susskind, who combined his ideas with previous ones of Hooft and Charles Thorne. So a UK, Canadian, and Italian study has provided what researchers believe is the first observational evidence that our universe could be a vast and complex hologram. Theoretical physicists and astrophysicists investigating irregularities in the cosmic microwave background have found that there is substantial evidence supporting a holographic explanation of the universe. In fact, as much as there is for the traditional explanation of these irregularities using the theory of cosmic inflation. So it was found that the holographic model was a better model than the standard model. And this is maybe because it's able to make a solution that cannot be described in terms of methods for finding an approximate solution to a problem by starting from the exact solution of a related predictions for large angle statistics of the cosmic microwave background radiation. So, simply put, what we experience in this realm will come from the quantum realm. So, I have a video I'm gonna show now. I'll put it in the description link. It's about the holographic principle to help you get a better understanding. But now I'm going to pull up. I already have the video up, so I'm gonna play a small portion of it for you guys. All right. Let me let me see if I can make this. I should be able to make this big for you guys. Yeah. So I'm gonna make it nice and big for you guys so you can see that. All right. So you guys can continue that video at your leisure. I'm going to leave it in the description link. But for now, we're going to continue. So here we are. So in philosophy, systems theory, science, and art, emergence occurs when an entity is observed to have properties its parts do not have on their own. So, properties or behaviors which emerge only when parts interact on a wider whole. So, when you apply this to space time, this is the biggest discovery of quantum gravity. So, remember, in quantum mechanics, before particles are measured, they have no location and no defined properties. So they exist as a wave function of possibilities they can take on. So in order for space to emerge, there has to be measurement or an observer. So the illusion that there is separation of particles um, in space is space, but not necessarily reality. meaning there is no separation. So Hang Yang from the Division of Mathematics and Physics at the Daehin University in Korea, he said the emergent space-time is a new fundamental paradigm that allows a background independent formulation of quantum gravity and opens a new perspective to resolve the notorious problems in theoretical physics, such as the cosmological constant problem, or the hierarchy problem, or dark energy or dark matter. So, space is not the only thing that emerges, though. The special theory of relativity, first described by Albert Einstein, was merely a statement of the realization that we were wrong, that distances in space and time are actually relative, they exist simultaneously. So, if this is true, then that will also mean that time too emerges from the quantum realm. And they have a time from quantum entanglement experiment results that I'll also put in the description link. So this explains that everything that we perceive as reality actually comes from a deeper layer. So Sean Michaels Carroll is an American theoretical physicist who specializes in quantum mechanics, gravity, and cosmology. And he said in an article, "Space Emerging from Quantum Mechanics. Mathematically, wave functions are elements." Uh, Wait, real quick, guys. Let me make sure I'm still on. Okay. He says that mathematically, wave functions are elements of a mathematical structure called the Hilbert space, or called Hilbert space. That means they are vectors. We can add quantum states together, or quantum states together are the origin of superpositions in quantum mechanics, and we can calculate the angle or the dot product between them. So we're going to skip over some technicalities here, especially regarding the complex numbers. If you want to see more about it, just look into the theoretical minimum for more. So the word space in Hilbert space doesn't mean the good old three-dimensional space we walk through every day, or even the four-dimensional space-time of relativity. It's just math speak for a collection of things. In this case, possible quantum states of the universe. End quote. So in mathematics, Hilbert space allows generalizing the method of linear algebra and calculus from the two-dimensional and three-dimensional Euclidean spaces to spaces that may have an infinite dimension. So a Hilbert space is a vector space equipped with an inner product operation, which allows defining a distance function and perpendicularly known as ontology in this context. So our world emerges from a collection of things. So on top of this, Brian Wentworth compared what we see in our universe with that of an emergent world in his work, The Emergence of the Physical World from Information Processing. And that's a PDF, another PDF that I'll put inside of the description. Everything here should be found in the description link. So he found 11 reasons why the physical world could be a virtual reality and why our reality is better explained from a virtual standpoint rather than by our fundamental space-time matter. So, for example, here are three things on this list that make more sense from a virtual case. So, the maximum speed, or nothing can travel in our universe faster than light. In virtual reality, it's maximum processing rate, meaning that a screen cannot transfer pixels faster than its rate. So in wave function collapse, the quantum wave function collapse is a non-local effect. In virtual non-local effects, processing is non-local with respects to pixels on the screen. Then there's quantum transitions. In quantum mechanics, an event is a series of state transitions. In digital transitions, a series is a digital movie with picture frames. So this adds on to the evidence that we already have. And let me pull up um, a screen with this picture so you guys can see. Let me see. Hopefully I'm able to put this back after I remove it. Um, oh shoot. Did I just All right, y'all. All right, I'm cool. I'm able to pull it back up. I was about to say, dude, I thought I stopped. I thought I stopped everything. I'm trying to get, yeah, here we go. All right. So, yeah. All right. So I was able to get the pictures up to show you the chart, right? So here's the chart. And you can see on this chart, you can see the physical outcome and the virtual cause. And I'll just, like I said, I already wrote a few, but I'll just touch on one more before I move forward. So the Big Bang is our physical outcome. The universe was created from a Big Bang event that also made time and space. Then there's the virtual cause, virtual reality creation. All virtual worlds arise when an information influx starts their space time. So you can see the comparison there. All right, so let's continue. I'll leave that up. Hopefully, you know what? I'll blow it up while I continue to read, so you guys can see that. So, um, right. So the next question is, what does all of this have to do with mentalism, and how did mentalism derive from this? So we've covered the first half, and now we're going to go into the second half where we're going to talk about quantum cognition. So quantum cognition is a new research program that uses mathematical principles from quantum theory as a framework to explain human cognition, including judgment and decision making, concepts, reasoning, memory, and perception. This research is not concerned with whether the brain is a quantum computer or not. So the mind acts similar to quantum superposition, and the maths of quantum mechanics behave similar to the fuzzy logic of human behavior. So, fuzzy logic is an approach to computing based on degrees of truth rather than the usual just true or false. So, Boolean logic, on which the modern computer is based, it may help to see fuzzy logic as the way reasoning really works, and binary or Boolean logic is simply a special case of it. So, the argument here is that although our minds can behave quantum mechanically, that doesn't mean that they are quantum mechanical and are actually still classic. So, classical computers can efficiently simulate the behavior of quantum computers if the quantum computer is imperfect enough. However, because they would need to unpack into classical bits, which also includes the way our minds and our brains are working, it would cause an exponential slowdown. So the thought of our minds not being quantum mechanical in some way, shape, or form is highly unlikely. So Matthew Fisher is an American physicist that showed that rats' psychology had been changed due to their quantum biology being altered. So from observing the rats, Fisher found two substances alike in all important respects, save for quantum spin, and found that they could have very different effects on behavior. For Fisher, this was a tantalizing hint that quantum processes might indeed play a functional role in cognitive processing. So, let me pull this video up, and I'm going to show two parts of this video. All right, so give me a second, y'all. Chrome tab. Is this it? Yeah, this is it. This is it. So let me see, because we're not going to watch the whole video. I just got to go see exactly where I see exactly where. So right. So okay. All right. So we'll start here.
Serendipitously, in 1949, it was approved in the United States for treatment of mania and bipolar disorder in the 1970s. You might well ask, and I did 4 years ago, how does lithium work? Well, you might well ask, in fact, how do any psychiatric pharmaceuticals work? And the answer is, embarrassingly, that we have no idea. The neuroscientists have no idea. The neuroscience community has basically no idea. And because if you're really trying to understand the effects of drugs on the conscious state, on the tenet of the conscious state, you really ultimately have to understand the biochemical mechanisms underlying consciousness, underlying awareness. When I was learning about lithium, I learned something that many of you know, the two stable isotopes of lithium, lithium 7 and lithium 6, which differ in the number of neutrons they have, be it 4 or 3. Both lithiums have 3 protons and 3 electrons when they're neutral. Now, if you dig up lithium from dried lake beds, which is where it's mined.
All right, so that was the first part. Let me go to the second part. 920.
Solar difference. So let me just assume this experiment is right and ask, how on earth could this possibly be that the two isotopes of lithium have an opposite effect on the sign of the mood of these female rats? Well, okay, there's a mass ratio of 7 to 6, not so big, but what's remarkable is the nuclear spin entanglement time. I showed you this 10 seconds. Well, it turns out that's for lithium 7. Lithium 6 is 5 minutes. I don't know about you, but my memory is not much longer than 5 minutes. And when I saw that, I was like, good Lord, could it really be that evolution had undergone the process where nuclear spins became qubits in a quantum processing in the brain, and that our brains are some sort of quantum computer? Seems totally.
All right, so let's continue. Oops. All right, and let me just pull up another picture for you guys, so y'all can see that similarity between the two sciences. right. All right, guys, give me 1 second. Be right back. Oh, sorry about that, guys. My apologies. Hopefully, you got time to just look at look at the picture. So sorry about that. Let's continue. So we need a conscious based physics. Why? So, since conscious thought processes can be modeled as existing in Hilbert space, with the evidence we have from quantum cognition, and with Hilbert space being where space time emerges from when you combine quantum cognition with space time, the simplest explanation is that matches the evidence is that consciousness is where space time emerges from. But remember, we have to take into account that we're talking about our physical world emerging from consciousness. We need to use classical physics, the classical physical model, when talking about consciousness to make that relation. So, this is why we need a conscious based physics. So the good thing is that there are sciences that allow for the creation of space-time to come from consciousness. Donald David Hoffman is an American cognitive psychologist and popular science author. Hoffman notes that the commonly held view that brain activity causes conscious experience has so far proved to be intractable in terms of scientific explanation. Hoffman proposes a solution to the hard problem of consciousness by adopting the converse view that consciousness causes brain activity and, in fact, creates all objects and properties of the physical world. To this end, Hoffman has developed and combined two theories: the multi-model user interface theory of perception and conscious realism. So, conscious realism is described as a non physical monism that holds that consciousness is the primary reality and the physical world emerges from that. The objective world consists of conscious agents and their experiences. So, what exists in the objective world, independent of my perceptions, is a world of conscious agents, not a world of unconscious particles and fields. Those particles and fields are icons in the MUIs of conscious agents, but are not themselves fundamental de- uh, denizens of the objective world. Consciousness is fundamental. And then there is David Toker, who presented the thesis back in 2013 about information idealism. Here's his thesis. My thesis consists of two parts: a philosophical study of consciousness and a neuroscientific study of time perception. So, for the philosophy portion, I examine the idea that information can serve as a metaphysically fundamental category to which consciousness can be reduced. I ultimately recommend a view that I call informational idealism, which is the that information is ontologically primitive, that the mental reduces to the informational, and that the material is ontologically secondary to both the informational and the mental. For the neuroscience portion, I tested the hypothesis that drift in mental context when I measured as the change in neural activity in brain regions that encode mental context is predictive of people's estimates of elapsed time. I found that although neural drift in brain regions identified as encoding mental context does not correlate with time perception, neural drift in caudate nucleus does predict estimates of elapsed time. Finally, the conclusions of both the philosophy and neuroscience portions were considered as potential tools which with which to solve various puzzles that arise out of the philosophy of time. So, conscious realism takes a bottom up approach using simple interacting conscious agents, replicating the wave function of quantum mechanics and the space time of general relativity are two things this method is really good at. So instead of the wave function just being a useful tool for predicting things in quantum physics, it takes the form it does, allowing you to derive conscious realism from physics. Also, instead of just making predictions from general relativity, it also explains how we get it. The maths involved with making these theorems include something called the combination theorem. The combination theorem demonstrates that systems of interacting conscious agents themselves constitute a single conscious agent, but compared to the other conscious agents, it is still distinct. Then there is Daniel Tooker and his proposal of information idealism. The conclusion derived from this is that both information and experience come before the material and are identical. Some of his conclusions are borrowed from the integrated information theory. So, integrated information theory attempts to provide a framework capable of explaining why some physical systems are conscious, why they feel the particular way they do in particular states, and what it would take for other physical systems to be conscious. So, thoughts and the information from thoughts and perceptions are identical with consciousness and also identical to entanglement. This was shown before when it was said that space time emerges from entanglement. So, space time emerges from consciousness. Let me just check my yep, we still on. We about an hour and 4 minutes in. So when you combine this view of relational quantum mechanics as a definition of consciousness as entanglement, you will get the same results as the combination theorem mentioned before. So the foundation of both conscious realism and information idealism is physics-based on how space-time emerges from consciousness. So you can see that both the physics and conscious base. So you can see that both physics um, that they are both physics and conscious based, both these methods. Rather than just asking simple predictions, they actually explain why things are the way they are. So instead of just making predictions from general relativity and quantum mechanics and not explaining them, we are explaining general relativity and quantum mechanics themselves from this conscious physics. So I'm going to show you guys another video. This is Entangling Conscious Agents by Donald Hoffman. Let me get that up for you guys. All right.
Am I out of time? 6 minutes, okay. If I'm going to solve the mind-body problem, I can assume that physics is fundamental, and then my burden is to get consciousness. Or, what I'm trying to do is the opposite. I assume consciousness is fundamental. Then, my burden is to show that all of physics comes out of it. Quantum mechanics and so forth comes out of this. And it does. So, this is an abstract agent dynamics where it's a very simple, each agent can only see one bit of information, 0 or 1. And you can actually program up these things. This is two agents passing information back and forth, zeros or ones. And it turns out that when you look at the long-term dynamics of these, you'll have to take my word on this. When you look at the long-term dynamics, the states of the two agents become entangled. You actually have an entanglement of this is the title of my talk. Conscious agents actually get entangled because they have different kinds of asymptotic long-term behaviors. And it turns out that when you look at that long-term behavior and write it down, so this is, the top was the conscious agent dynamics long-term behavior. And then if you write down the wave equation for the free particle in quantum mechanics, it's exactly the same equation. So we can actually read off, this is the non-relativistic case, you can actually read off a one-to-one mapping between non-relativistic quantum mechanics and this agent dynamics. And I won't go through it. This is the actual read-off of the equivalence between space and time and aspects of consciousness. And if you're interested, I've got a paper that has the details that we don't have time for. But you can even read off energy and momentum from this. Now, that's non-relativistic, and I'll close by the relativistic. I mean, the ultimate thing is we want to have a relativistic quantum theory falling out of a theory of consciousness. And the direction I'm going on that, and I'm starting to collaborate with Chris Fields and some others on this, is to actually take a system of two conscious agents, and it turns out it can be represented by something called a geometric algebra that I've written down there. And that geometric algebra is precisely the geometric algebra that describes the relativistic quantum free particle, massless particle. So the idea is that we can get space-time coming out of this, Dirac spinors, and ultimately, using Penrose twisters, maybe even quantum gravity. So the idea is that this program, for it to be successful, has to start with consciousness and give us all of quantum physics. And then we've solved the mind-body problem going the other way.
All right. So let's continue. All right. Let me get one of those pictures back up for y'all. All right, so let's continue, y'all. Where are we? So this explains why a theory that explains why things are the way they are is better than a theory that takes knowing why things are the way they are for granted, because both these models have their starting points from consciousness. So solving our problems may make more sense if we start from conscious-based physics. So in the same way that quantum mechanics supersedes classical mechanics, or how Einstein's theory supersedes Newton's theory, these could be considered superior models. So our frame of reference is irrelevant of whether or not these are separate systems, due to consciousness being identified with information as was previously described, and quantum mechanics relational nature is brought into play. So when we are looking at it from a higher position, entanglement happens when two things are in superposition together from a lower frame, though neither sees the other two as in superposition. So on a lower frame, they will represent separate conscious minds, but on a higher frame, they will be of a single mind. So it is with the combination theorem that integrated information systems would achieve the same results. So no matter the case, though, a single conscious agent will arise out of any wave function entanglement on any system. So this is where God comes from in religion as the all, the wave function of the universe, and the universe itself is in the universe in its entirety would be contained in one single mind. So taking all of this into account, the principle of all is mind, or mentalism, can be derived fully from this physics as well as the existence of God. So um, beings being gods, but not actually God themselves, also is explained by the relational nature of conscious agents. So, in this model, we are able to understand the relational nature of entanglement and conscious states or agents. The all would consist of all these separate agents in itself. At the same time, though, the all is distinct from all of these other agents. All right, and I'm going to show you guys one last video before we wrap this up, kind of drive this point home. So just give me 1 second and I will get it up. Often theory experiment. Here we go. All right. So
being looks at the cat. I am conscious. Therefore, conscious.
All right. So let us continue. Let me get you guys one of those pictures back up. Oops. All right. So in cognitive science models, in cognitive science, the models of modern and quantum physics are where the Hermetic principle of mentalism can be fully replicated from. A scientific description of God is also derived from this model, which in religion is mainly just discussed. But through conscious based physics, we have a scientific derivation. So we can also derive the other principles as well from these sciences. And we are going to explore the other principles in future videos. So despite this advanced physics that we just went over, we don't need it to reach our conclusions of mentalism. The basic facts of reality is where we can also derive the principle of mentalism. And I'm going to create some videos in the future to describe that. So consciousness is an undeniable fact of our reality. Uh, like I said, I do not have any videos on this channel showing this yet, but I will. So hit the notification bell so you can see that video as soon as I come out with it. But consciousness can't be reduced to anything else given the hard problem of consciousness. So in reality, consciousness is fundamental. Consciousness is identical with experience. And if this is the other way around, or the brain is producing experience, then experience itself is non-experimental, and we're left with a contradiction. The mind cannot be reduced to matter, is the contradiction. So, due to the previous description of the physics, and where space-time emerges from, consciousness is fundamental, and from consciousness emerges space-time. So here mentalism is still true. So the only thing that can interact with consciousness is the mental, because the only thing that defines interaction in physics is shared properties. So because the only substance which we intuitively know of is consciousness that interacts with mental anything that doesn't have shared properties of experiential or mental states cannot interact with consciousness. So because consciousness cannot be reduced to anything else in basic physics, we can know the principle of mentalism to be true. So the simple conclusion, without being reduced beyond necessity, is that all is mind, God exists, and mentalism is true. So